Hello people, welcome back to my channel. So today in this video we'll be seeing what is model overfitting and underfitting in decision trees. So we have already seen what are decision trees and what is decision tree capable of in doing machine learning. So today let us understand the two most important terms in machine learning, or which are associated with machine learning, particularly with decision trees. That is, we have the underfitting and overfitting. So let's get started. So basically what is meant by fitting, first of all. So fitting is to fit a model, which means you mean to fit a curve. So a curve can be something like this, or it can be like this, or it can be some in a random shape. So you need to fit a curve. So this is represented in 2 dimensions as y-axis and x-axis, and you have to plot this curve somewhere like this, and it would be in this way. Now what happens is that you have your data set. So it's divided into a number of rows and a number of columns, and you partition into some, say for example 67%, and you have 33%. So this will be your test set, this will be your training set, and this part you used to create your model, or you used to develop your model, and this part you just used to validate your developed model. So in this process you will get some kind of error. So that kind of percentage error you mark it and you obtain and you keep it aside, and here also you will get some percentage error. So these are 2 errors which you do when you train your model. So you have some training error as well as you have some test error. Now what underfitting means is that when your training errors and test errors both are large, means it's very high, it's not unacceptable. In that case you call it as underfitting. Means this majorly happens when your developed model, developed classification model, is made very simple. So in this case underfitting happens. So underfitting is mainly detected with the help of bias detection. So various techniques are there in order to determine the underfitting. So say for example you have something like this. So here what you have on the y-axis, you just plot the percentage error which you have from this part, that is training or test error, and on the x-axis what you have is basically the number of instances which is used for building your model. So underfitting curve, say for example it's like this, and you have some instances, say you have some labels like this and some labels like this. So some part of it may fall in this category and some part may fall above this line. So this is not well fitted, or this curve is not well fit into this particular graph. So this is mainly the description of goodness of a fit. Means how well the given observations or given samples are being fitted into that particular curve. So this is the case of underfitting. Now what do you mean by overfitting? Now you have this kind of model, so you build your model and you have your training going very well. So if the training errors are very good but the test errors are very large, so if the train errors or the training errors are less but test error is large, so in this case what happens is you have the problem of overfitting. So overfitting is mainly detected with the help of variance. So you have various tests for detecting the overfitting of a curve. So the curve, say for example you have the similar curve and you have percentage error on the y-axis, and on the x-axis you have the number of instances So say for example you have some instances like this, so we need to classify it properly. So what overfitting does is, your curve will be something like this. So this is not a accepted curve. So overfitting curve would look something like this. So this is not the case. So you have to like properly fit the data or properly fit the observations and instances. So a perfect fit or an accurate fit would be something like this. So you have some instances like this and say some instances like this. So if your curve is something like this, which well classifies which instances are where and which instances are on the other side, then this would be a perfect fit. And this mainly happens due to the bad performance of your developed model. So if your model is not well good, or if it does not performs well good on the test errors and training errors, then you may have the problem of overfitting as well as underfitting. So well, that was all regarding in this video. So hope you guys enjoyed this video. If you got educated watching this video, please do like, share, comment, and if you have any queries, and also do subscribe to my channel. Thank you very much for watching this video.